Okay, hello everyone and welcome to my first video and the first video on this satellite rotator. Before I get started, apologise for the noise. We are right by a road here and there's people going back and forth and it's also raining. And also obviously apologies for the production value. This video, the series and channel in general is more for my reference than anything else. I like tracking, keeping logs of what I do. I don't particularly enjoy writing. Video is a good option. So with that out of the way, what is this? This is a commercial satellite rotator. It's designed to be mounted on the top of a vehicle, usually a van. And it can rotate, go up and down, find a satellite, probably a geostationary broadband satellite, lock onto it and give you broadband wherever you are in the world. This particular one came off a commercial vehicle. I know that, well, I think that's because this company here does that. They do commercial vehicle communication systems. They didn't make this. This dish is, as far as I can tell, made by a company out of Canada called C-Comsat. They do these for commercial and for like motorhome RV use. This particular one, I believe, is for broadband. It's the model is the iNetVu, which is iNetVu 985, I think. The 985 being the diameter of the dish itself. I think that's the model. 985 isn't a serial number. It's really hard to find information on these because they cost tens of thousands new as far as I can tell. But because they're commercial products and they're sold through dealers and stuff like that, finding any straight answers on anything is fairly difficult. So how did this one come into my possession? The magic of Facebook Marketplace. Some guy had bought a van that I think had been a demonstrator or something for this company, and they gutted the interior but left this on the roof. Whether they did that knowingly or not, I don't know. But the guy sold it chucked it up for 50 quid. I went in and bought it. And yeah, I'm not going to use it for broadband. I couldn't anyway. I don't have the controller. I just have the rotator itself. I'm going to use it for tracking other satellites, starting with like weather, satellite imagery and stuff like that, because it sounds interesting. So what exactly have I got here if I don't have the controller? Well, I have I have the entire dish assembly itself. But there's no logic on it whatsoever. I'll go over the electronics in a minute, but the basic idea of what I need to do is figure out how to control it. So run the motors, use the sensors to know the positioning of the dish, replace this LMB with a helix or something to pick up the satellites that I want. And that's pretty much it. It sounds straightforward, but it's going to be quite a lot of work. So, as I said, I don't have the controller, but the controller wouldn't have been of much use to me anyway because it's designed for geostationary broadband satellites, which are not what I'm going to be talking to. Thankfully, whoever gutted the van originally left the cables on the rotator side intact and just chopped up the other side, which I don't need. This was connected when I got it, and that's the cable for the motors, which is good to have because for the motors I'll probably reuse the original wiring with this connector because it's there and it works, and the motors are very straightforward. These two are RF and they're actually going to be torn out. I'll replace them with some different coax more suited for what I'm doing, and I'm replacing the original LMB anyway. And this has two because it did transmit and receive. I'll only be doing receive. And this one is the more difficult one, and this is for the sensors. This thing itself has a whole bunch of sensors on it. I'll go over in a minute. But this cable is for connecting those sensors to the controller. These didn't connect straight to the controller. There was an intermediate cable, which this is part of. I looked up this part number here, and it just comes back to it's a power cable basically, which is good because that's what I need. Now the sensors, I don't know if I'm going to be able to use. They're obviously, they're not labeled. There's no labels on anything in this basically. Some of them are proprietary. So I don't know if I'm going to be able to use the original sensors, but thankfully I don't have to, because the controller is separate. The actual electronics in the thing itself are incredibly straightforward. So I'll give a quick overview, starting with this at the back here, which is the elevator motor. So there's a motor here. Both the motors on this one and that one at the front there, are 24 volt DC, 5-ish amp, bog standard DC motors, brushed motors. Brushes are here. They both connect through an 80-to-1 reduction gearbox. The elevator also goes through another gear reduction and then yet another gear reduction here, which means the motor actually spins very fast for not a lot of movement, which is what you want in this application. But it means manually actuating the arm, as I had to do with no power, took a hell of a lot of turns. It's all very straightforward. There's a few sensors on this gear here. This one here, best I can tell based on the service manual I found, which is a service manual in that it tells you how to swap parts. It doesn't actually tell you how to fix anything. But this is an angle sensor, so it measures the angle of the arm. I'm not sure in the original application whether that measured the angle relative to the base or relative to the ground. I'm assuming ground because that's more useful in satellite work, and it has end stops here, one at each end, these little magnetic, I guess, Hall effect or reed switches, which act as the end stop so it can't fold too far either way. This obviously controls satellite elevation as well as stowing. This boom arm here with the receiver LMB on it is free moving with this little hydraulic strut here. So as this arm folds down, this folds up, and the dish eventually rests down here, and the dish rests on here when it's folded down. I'll insert a picture of this in the back of my car because it is quite amusing, this massive thing inside the back of my tiny little car. So yeah, that sort of motor to it. Adjust the elevation and allows it to stow. And the other motor is at the front here. Again, same motor, same 80-to-1 reduction gearbox, but this one controls the rotation. And in fact, this one you can turn by hand and you can see it move. So yeah, both motors are free, both gearboxes are free, which is good. I'm probably going to do an oil change on these gearboxes if I can get them off, because the only date code on this whole thing are on these gearboxes, which is January 2011. So it's been 14 years now, and I don't know if these have ever been serviced, so I'll get on with that. In terms of sensors on this, the only sensor on this motor I think is this here, which is a rotary encoder. So it will know the position of the arm in relation to the base. Now, what it can't work out with a rotary encoder is, unlike the angle sensor, is the position of the arm, the rotation relative to the earth. The way it does that is up here is a electronic compass mounted, so it can use that to determine which direction the dish is facing in. There's also one more sensor here, which is a simple micro switch that's actuated by this arm impacting it, so it knows when it's stowed, I think is the idea of that one. I don't know if I probably won't actually use this in the final one. It's a simple switch, 2 pins. I can check it works. I'll leave it there. I probably won't hook it up to anything. I don't need that. Any way of knowing when it's stowed, really, I can look at it. So, how am I going to make this do what I want it to do? First things first, I need to make the motors turn. Now, these I said are 24 volt DC 5-ish amp motors. So I've ordered some very cheap, very basic DC motor controllers from AliExpress, which are on their way, and I'll hook those up and hope the motor works. Now, I think in the original thing, these motors weren't speed controlled or anything. Because they go through such a high reduction, I think the motors can spin at their full speed and the dish will turn nice and slowly. I think that was the intention. In my final setup, I'll probably PWM control them because it lets me ramp the start and stuff like that. But for just testing, tell the motors to run and hope it all moves. I see no reason they wouldn't. Both motors are free and quiet when you turn them by hand. No binding or anything, so I think they'll be fine. If not, I might have to clean the brushes, something like that. Once those motors are working, I need to figure out the sensors. Now, as I said, there's no logic in this. The sensors just all connect up out through here to the old controller, so I can replace any of these sensors that I can't get to work. The angle sensor, I'd like that would be very useful for satellite tracking, but if I have to replace it, so be it. End stop sensors should be straightforward. I imagine they are Hall effect switches or reed switches, so they'll either, the resistance will change or they'll just turn on or off. So I'll be able to tap into those, I imagine, no problem. The compass, unless I get really lucky and it's a standard serial interface, which I will investigate, I'll crack it open, see if there's any part numbers in there, because this, I don't know if you can see, it's actually just iNetVu branded, so it's presumably a proprietary part they've got there, so I might not be able to use that, but there are plenty of off-the-shelf options I can try in its place. The compass isn't so important because I'm going to know where this is. I can take some manual measurements, and satellite tracking isn't something I'm particularly familiar with. I picked this up because it was cheap and it seemed like a fun project. I'm still learning at the time, so I don't know what you need, but to my understanding, as long as you know the relative position of the rotation and the elevation, you can track a satellite without knowing its actual compass direction, but it will be nice for it to work. So yeah, once I know the motors work and I can talk to the sensors, it's going to be a case of writing some software to talk to it and control it. Now, the way I'm going to do that is using a microcontroller, and I'm going to implement, probably, there's a couple of standard in sort of the amateur radio space, a couple of standard open source satellite rotator protocols that are used by things like SatDump and whatever it's called, for tracking satellites. So I'll implement one of those. I can then hook it up to a computer and track a satellite of my choosing fully automatically, which would be nice. That's obviously quite in the far future, a lot of work to be done between now and then. But of course, to actually receive anything useful from the satellite, I need to replace this. This LMB is only for broadband, essentially. Thankfully, it's a separate module, and I've already undone the bolts at the front here and undone the coax, so it actually just, if I can get, okay, no, it's not. Okay, there we go. Cool on this cable. Okay, so that comes out, completely separate piece that I have not really any use for. Put that out of the way. And then on here, I've got the old coax, which I'm going to remove. The compass is up there. And here, where the old one was mounted, I'm going to measure up and probably 3D print a bracket that will allow me to mount a coil of my choosing wherever that needs to be. I need to learn how to do the positioning and adjustments of the coil and stuff like that. So yeah, it should be, assuming everything works and I can talk to the sensors, a reasonably straightforward project in terms of the actual component parts. It's just going to be a bit of a learning curve for putting it all together. So in terms of videos on this, I'm not going to do a watch as I work series. That's not the intention of these videos. These videos are more for my reference than anything. I hope people get some useful information or enjoyment out of them, but I'm just going to make these as and when I have an update to share. So yeah, I think that's about it for this video. The next video will be when my motor drivers and power supply come in. I will hook all that up and make a video, hopefully showing it moving them out. So yeah, I think that's everything for now, and I'll see you in the next video.